Okay, so let me start then the lecture. So, as I was saying, we have completed four chapters on fundamentals of solid state joining, then macro deformation based joining, micro deformation based joining, and diffusion based processes. Today, we'll take up the new chapter that is on the adhesive joining. Okay, so we'll talk about its the fundamentals and some advantages, disadvantages in today's lecture, and thereafter we'll go into the further details like process parameters and the factors affecting the performance of adhesive joints. Okay, so let me share the screen. So I hope you can see this white screen.
Yes.
Okay, good. So the topic is adhesive joining. This is also known as the adhesive bonding, and there are number of hybrid joining processes which have been developed in combination with the adhesive bonding. Like the weld bonding is one typical example where the spot welding coupled with the adhesive joining is is used, and particularly this kind of the combination helps to increase the load carrying capacity and the fatigue performance. So to exploit the advantage of these properties of the weld bonds, this is extensively used in automotive sector, in aircrafts. Okay, but how these things happen and how to identify that what is the contribution of the spot weld, what is the contribution of the adhesive joint, or that about that we'll be seeing little later. So what we do in adhesive joining, the process principle is very simple. Here the components to be joined, mostly the lap joining is performed. The type of the joint which is used in adhesive joining is the lap joint configuration. Okay, so the components to be joined are placed in lap configuration, and then adhesive is placed in between and the two components. Okay, so this adhesive, just like in brazing and shouldering, it must spread and wet the surfaces for good bond. You see, if the adhesive is not wetting to the substrate surfaces, which in case of the adhesive bonding is termed as adherence. So if the adhesive is not wetting the adherents, then its spreading will be limited. You will find a lot of unbonded zones, and the joining between the adhesive and the substrate interface will also be very weak. Okay, so the spreading and wetting of the adhesive with the adherent surfaces is very important, and after the application of this adhesive and its spreading between the adherents, we allow some time, so that is what is called curing. So during this period only some kind of we can say as a solidification or little hardening. So both kind of words can be used, hardening or the solidification of these adhesives can take place. Now this curing can be at a room temperature or at a high temperature. So depending upon the type of adhesive and its composition, many adhesives have been developed which gets cured at room temperature also and offer the desired strength, while there are many which needs the high temperature exposure for curing purpose, and after the curing only you get the desired mechanical performance from the adhesive joint. Okay. If you want to see the typical adhesives, just like a gum, if you see just like any kind of gum, paste, or even cement, glue, all these are like more commonly you must have heard Fevicol or M-Seal and number of other commercial adhesives are available. Okay. All these are various types of the, like few, there are various categories like natural adhesives you get from the nature, from the plants, or they are synthetic adhesives. Uh, these can be organic or inorganic kind of the adhesives. We will not go into those details. What we have to see is like whatever these adhesives are, these must wet the surface and form the good bond. Okay, so what are the prerequisite for having a good adhesive joint? You can say a requirement kind of thing. Requirement for good adhesive bonding. So you can say the you see the low viscosity or fluidity of adhesive, so that it spreads and wets the surface. So spreading and wetting is realized. Wetting of the adhesive with the adherent is realized, and this is also affected by the presence of surface cleanliness. Okay. So it is very important, like spreading and the wetting is certainly affected by the surface presence of surface impurities, and so it is important that the surface is clean and free from all these impurities. So presence of, you can say, surface impurities, or indirectly you can say surface cleanliness affects the wetting and the spreading. And if the surface is very impure, lot of impurities like oil, paint, etc. are present, then there may not be any wetting. So no wetting, no bonding, and a very poor or very weak adhesive bond strength will be obtained in that case. So you can say indirectly cleaning is very crucial. Cleaning or surface preparation in adhesive bonding is very crucial, and a range of the processes like the mechanical cleaning from wire brushes, abrasive, emery paper, and then there is a chemical cleaning like the acidic and the basic cleaning in ultrasonic environment. So all those things are done to make sure that surfaces are free from the impurities, so as to ensure a good bonding, a good wetting of the adhesive with the adherent surfaces. Okay. So these adhesives are uh, classified based on the certain, there are multiple types of the adhesives. So how to any classification is done just to facilitate the better understanding and to see that in which group they fall in. otherwise it doesn't help in any way. So you can say simply the classification of the adhesives. This is done based on the obviously certain technical or certain parameter has to be used to classify the adhesives. So one simple way of classifying the adhesive is that the in which physical form adhesive is present. Physical form of adhesives like liquid adhesive or tape adhesives. Okay, this is one. The second is like which type of the chemical, what is the chemical formulation, chemical type of the adhesive. So there is like silicate adhesive is one, epoxy adhesive is another common category. Okay, then the kind of the bonding material bonding which is facilitated, material bonding. So here for joining of papers, okay, or for joining of the metals, then metal and the plastics. So depending upon the kind of the uh, uh, the the bonding material, these are classified. Then we have the based on the application approach, how these are applied, application approach. So there is like hot setting adhesives and sprayable adhesives, sprayable adhesives, so which can be applied through the spraying. Okay, so if you see in this case, in case of the adhesive joining, there are number of similarities with the brazing and soldering, as well as number of dissimilarities. So the brazing and soldering, in these cases what we do, we heat the base metal but not up to the fusion or the melting temperature, so the base metal remains in solid state. Okay, the same is here also in adhesive joining. The base metal remains in the solid state, remains in the solid state. Okay, so it is fine, both are having the similarity, and in both the cases the heating temperature is moderate. You see here the low heating temperature during the development of the bond, and here moderate heating temperature, it is not very high, so moderate heating temperature, just like in fusion, it is not like in fusion only, so the moderate heating temperature depending upon the like whether brazing or soldering or the kind of filler metal which is being used. But in adhesive joining, the very temperature, very low heating temperatures for the joining purpose, maybe 150 or 200 250 maximum kind of the temperatures which are used for processing. Okay, now as far as the dissimilarities are concerned, okay, in case of adhesive joining, there is no actually metallurgical bonding, but some kind of the IMC or the metallurgical bond is formed. Metallurgical bond is formed in case of the brazing and soldering. So this is one difference. Okay, normally heat is used for curing and for proper spreading to ensure that the adherents remain in position and the sound weld joint is formed and the desired thickness of the adhesive is achieved. We use pressure as well. So pressure may or may not be used, but here there is no pressure as such in case of the brazing or soldering processes, there is no pressure which is used. Okay. In brazing and soldering, what we do, although there are a number of methods, one of the most common method is like you heat it and then place the filler metal outside so that after melting it spreads. Although in deep brazing, entire assembly is dipped into uh, the molten bath. Here what we do, here the adhesive is pre-placed. In adhesive joining, adhesive is pre-placed. Although there are a number of other approaches, so this is one of the more common approach where adhesive is pre-placed between the pane surfaces and then applied pressure so that it spreads across the uh, surface or the entire frame surface. Okay, so this is about just for a little better understanding of comparison between the adhesive and the brazing and soldering. In both the cases there is no fusion or melting. Adhesive is a low heat input process, while the brazing and soldering is a moderate mm, temperature process where a little higher heating is performed to develop the joint, and there is no metallurgical bonding in adhesive joining, while in other case there is some kind of the metallurgical bond which is formed through the IMC formation at both the braze or solder joint and the substrate interfaces. Okay, and normally heat is applied in case of the brazing and soldering, and while heat and pressure both are used in case of the adhesive joining. Okay, so this was about little comparison uh, of the of the brazing and soldering. Okay, so important features of this like important features in adhesive joining, like the certain kind of the characteristics that are important in adhesives for joining purpose. See, whatever we use, so for characteristics in adhesives for joining purpose, this is one, and other important aspects that should be kept in mind while making the adhesive joint. So one I have already said, like the good wetting of the adherent surfaces by adhesive. This is one obvious requirement, and like you must have seen the curing time. The few things harden very quickly, like you must have heard araldite kind of thing, quick fix. So what they do, the moment you apply it hardens immediately, so the time available is very very short. So there has to be enough time for curing and handling of the joint, so that you apply, then you put the pressure so that it spreads, and then little curing, the curing subsequently leads to the development of the joint. So it should give enough time, basically enough time for spreading and then subsequently hardening. Okay, whatever the adhesive is selected, you see that there are a variety of adhesives. So accordingly, so these adhesives vary significantly in terms of the strength and their high temperature stability. Like few start decomposing above 80 degrees centigrade, while few others sustain even up to 250 degrees centigrade. So there are a variety of the adhesives now having the different capabilities. Okay, so high temperature stability is one aspect, and the strength requirement. Okay, so what kind of the strength that can be offered? There are many structural adhesives which offer reasonably good the joint strength, like 20 MPa, 25 MPa, even 30 MPa. So, but certainly these will not be offering the joint strength as we get in typical belt joint. But uh, they offer reasonably good joint strength when it is coupled with the hybrid joining. So some kind of the metallic joining clubbed with the adhesive joining, then your performance is enhanced significantly. Just for an example, like say if you take one joint like this, develop a spot weld, okay, and then perform the fatigue test. It may give you life of say 10,000 cycles, but when spot weld is clubbed with the adhesive joining, okay, then it may lead to the like 15,000 also or 20,000. So significant increase in fatigue life is realized, especially when the uh, adhesive joining is combined or clubbed with the other joining technique. The reason for this is very good stress distribution. So uniform stress distribution reduces the stress localization, especially in the periphery, at the periphery of the spot which is being formed, leading to the higher stress concentration, and that in turn is reduced by the presence of these adhesives. So certainly we have to consider the strength of the adhesives and the high temperature stability when we are looking for the performance, desired performance. Okay. So Surinder, can you give some idea or input from your side, the kind of the adhesives or the kind of adhesive joining, if at all used in your industry? Hello.
Yes, sir. Sir, hello.
Yes, 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 I can hear.
Sir, that's what. For two-wheelers, we don't use any adhesive joining, but like it is mostly used in four-wheeler industries, sir. Like maximum they'll be using structural adhesives, like which will be curing at around
Ah,
like
room temperature
like,
curing automatically. Okay.
yeah.
Yeah, so that is the kind of in automobiles these are not may not be in two wheelers, but in four wheelers and in aircrafts these are extensively used. Even in helicopter rotors these are extensively used because they offer huge improvement in the fatigue life of the joint. Anyway, it's fine. Okay, so let us go ahead with the further few more points like. Another important aspect that we should consider here is like whatever adhesive we use, you see, all the materials will be showing some kind of the alpha or thermal expansion coefficient. So the difference in the alpha value should not be much actually. So not much contraction or shrinking should happen in case of the adhesives, you see, uh, due to the heating and cooling cycle being imposed. Otherwise it will be leading to the thermal stresses or the residual stresses at the interface. So there is just a little cautionary note, not much contraction or shrinkage of the adhesive should happen, or the joint design should facilitate that such kind of the residual stress development is minimized. Okay. The next point is, so this was about the like the contraction stresses, contraction or the shrinkage stresses due to the adhesives. The next one is the certainly the cleaning and the surface free from the impurities. That is very crucial for the good cleaning. And whenever the joint is developed, you know, there will always between the two sheets when these are being joined, initially there is a air when you apply the adhesive at the interface. So there should be enough opportunity for escaping of the air and the gases which are present at the interface, so that sound adhesive joint is developed. Otherwise a lot of unbonded regions will be left in there. So enough scope for escaping of the gases or air is there, so that entrapment at the interface is minimized. Okay. So I think that's these are few important points which need to be kept in mind while while carrying out the adhesive joining. Okay. As far as the principle of operation is concerned, what is the important condition for sorry for this wetting, regarding the principle of operation, there is a one, or you can say the two important aspect. One is the wetting, and the second is your actually it is wetting only. Wetting, once the proper wetting is there, then the adhesive type of the adhesive will dictate the joint strength basically. So the wetting is affected by the two aspects: the free surface energy of the, the base metal and the adhesives. This is one. And the second is the, the properties, physical properties of the adhesives, which, which are there in form of, the viscosity of the adhesives. So there is a simple concept like the free surface energy of the adherent. This must be higher than the free surface energy of the adhesives for good wetting. Okay. Presence of surface impurities at the adherent surfaces, at the adherent surfaces, it lowers the free surface energy. Okay, so that makes the wetting and bonding difficult. Okay, that is why it is very important to make the surface very clean. Okay, so whether it is the wire brush or the emery paper or abrasive papers, or some kind of the chemical cleaning is performed just to eliminate or remove all these impurities present at the surface. Few other there is one more mechanical method that is called grit blasting, which is also used for the mechanical cleaning. The surface must be cleaned. Okay, and when the viscosity of the adhesive is low, it will allow the easy spreading between the adherent surfaces, and if it spreads properly, then the bonded regions will be high, and the possibility for the entrapment of the gases and force, that will be very limited. Okay, now coming to the advantages and the limitations, those are really very interesting. So coming to the advantages of the adhesive joining, the one and very probably important aspect of the adhesive joining is in the dissimilar metal joining. Okay. It allows the joining of the metal 1 with the metal 2 without any issue. Similarly, it allows the joining of the metal with the non-metals. Okay, so this is the one typical feature which is extremely extensively exploited. Okay, another important thing, when the two dissimilar metals are joined, you see, there is always possibility of the galvanic corrosion. In corrosive environment, there is a possibility of the galvanic corrosion in corrosive environment. Okay, especially in case of the dissimilar metal joining. When the adhesive joining is performed, the adhesive acts as a thermal insulator or electrical insulator between the two. The two are being joined, but when the adhesive is used, it acts as an electrical insulator. So your circuit is not completed to facilitate the galvanic corrosion. Okay, this is very interesting one. Okay, then you can see, you see, it can certainly be used for joining the metals having the high alpha difference, because there is no extensive heating, so even if the alpha value is different significantly, it doesn't affect much. So this is particularly true or depends on the size of the components being used. Number one, size of the components to be joined, or you can say section thicknesses. Okay, normally adhesive joining is performed on very thin wires, thin sheets, films, foils, sheets, etc. Okay, so developing the a reasonably good joint of the metals having large difference in the thermal expansion coefficient can certainly be done with very great ease. Okay, even metallurgical incompatibility between the two metals doesn't come into as a barrier. Okay, then next is the bonding of the, it can be very easily and effectively used for joining of the multiple thin sheets. Joining of thin sheet is not really possible using your normal fusion welding. No, if your thin foils, films, sheets, they easily cause the melt through, difficult to control over the molten metal, molten weld proof. So in those cases, when multiple thin sheets or foils or films are to be joined, you see the adhesive bonding plays, even wire joining with the sheets or the films, then these can be very easily realized using the, so sandwiched panels and the multiple layered structures of thin sheets, those can be easily developed using the adhesive joining. Okay. Then next, a very important and a very interesting aspect of the adhesive joining is this, right? Very low processing temperatures which are used. Okay. Processing temperatures typically for adhesive joining, it may start from the room temperature, that is fine, but even if the curing is done, it is usually done in the range of, like, say, this is the most common range, 160 65 to 176 degrees centigrade. This is far lower than the your shouldering temperature. Okay, so this is one aspect. Okay, and there are many adhesives which have been developed nowadays which cure even at the room temperature, because there may not be any scope, opportunity and possibility for curing at a higher temperature. Most of these adhesives perform pretty good up to 82 degrees centigrade. Okay, in the moderate range of the humidity, 70% humidity. See, there are issues at higher temperature, these starts getting decomposed, and same is true for higher humidity conditions. Okay, but there are few adhesives which have been developed, they can perform even well up to 150 degrees centigrade, or even there are few up to 250, but these are very costly, difficult to process. Okay, so this is the common range for the common operational range for the adhesives for which these are used. And there is another aspect, is there are few adhesives which perform or which retain their strength even above their curing temperature. This is interesting. If you see, in case of tempering of the Q&T steel, the moment you go at a temperature higher than the tempering temperature, your properties are compromised. But that is not true in case of the adhesive joining. Some of the adhesive joints, like you are doing the curing at room temperature or say at 150 degrees centigrade, but there is a possibility that joint may retain its strength even little higher than the curing temperature. So that's the very good side. Few adhesives retain their strength even at a temperature above the curing temperature. So this is very interesting aspect as far as the adhesive joining is concerned. Okay. The another important aspect is like when adhesive is joining is performed, it works in number of very good ways. The first thing is a proper spreading throughout the area helps in sealing. Okay, and making it leak tight. So this is one. It doesn't allow the seepage or entry of the chemicals or the moisture between the components which are being joined. That's one. So the sealing is facilitated. uh, uh, Sealing, adhesive joining facilitates the sealing of the gap, makes it leak tight, and which in turn prevents the entry or the seepage of um, the chemicals or the moisture between the adherents. Okay, then you see another interesting thing is this adhesive, as I have said, acts as a thermal and electrical insulator as well. Electrical insulator. So because of this, it is extensively used in especially electronic industry, in PCBs. uh, the adhesives help, it is helping to join the wires, at the same time it is keeping them separate as well electrically. So this kind of the feature, acting as a good electrical and thermal insulator, it is used extensively in the electronic industry. There is another interesting aspect only. Usually, these adhesives are electrical and thermal insulators, but if we add fillers in form of, like, say, the carbon fibers or the metallic powder, okay, then these can show the electrical conductivity as well. So if there is a need, then you can have the electrical conducting adhesives as well, which are filled in with the carbon fillers or the metallic powders. Okay, so that's that's very interesting part, like you can have the electrical conducting adhesives as well. Then we have the another interesting, the feature of the adhesive joining. As I said, let's say, this is the top view of adhesive joint. Typically this is what we get actually. Okay, say in adhesive joining, this area is typically of 1 inch by 1 inch. Depending upon the size and purpose and load requirement, that's another thing. So, whenever the adhesive joint is developed, the adhesive is expected to spread over the entire surface. Okay, so when it is spread over the entire surface, then unlike the spot welding, in case of spot welding, whole of the stresses were getting localized around this point. But when you do the adhesive joining, the entire stresses are distributed across the section. Okay, so that's very good part. So basically, what we say, uniform stress distribution. This in turn reduces the stress localization or stress concentration. This in turn improves the fatigue life significantly. Okay, so let's take an example. Like, this is the weld bond having the spot weld, okay, and adhesive joint. Spot weld make like this, 1 2 3 in the same line, right, and adhesive joint subjected to the fatigue loading like this. Now, when let's say tensile test is performed, how does it behave? Initially, you know, it will go like this is one, then again it will go like this. So this dip or deviation that we are getting is an indicator of the adhesive failure. Then it goes with the metallic failure. So if you go just with one, then it will go like this. No, if it is either adhesive or the metallic bond, then there will be just one curve like this. Here, the direct failure from the joint interface. So what the two stage failures can be observed in case of the weld bonds. or hybrid joining, where the first the adhesive will fail, then subsequently your spot will fail. Okay. This improved stress distribution has been reported to improve the fatigue life significantly, and especially one typical example is here helicopter rotor fabricated using the metallic joining plus the adhesive joining combination. This resulted in significant improvement in the fatigue life, like 1.5 times to the 2 times of the fatigue life. The magnitude by which the fatigue life was improved, 1.5 times to the 2 times. Okay. Then we have some other interesting and very good looking features. Like the moment you make the spot weld, what you get the depressions and impressions at the surface of the base metal. So this leads to the damage the appearance. Appearance is compromised basically when spot welds are made. When you make the adhesive joints, there is no compromise with the appearance, there is no decolorization, there is no, because decolorization may also be caused at the surface due to the high temperature rise. Even impressions or depressions or the spots can be formed at the surfaces. So all those issues are resolved actually. So you can say the appearance wise the adhesive joint result quite good surface. That's why it is extensively used in number of the car body parts for the joining purpose. Okay, so that's one. The second is, which is also very interesting, since the adhesive joint, whatever is being made, you see, the adhesive acts as a very good vibration and sound damping. Adhesive offers very good damping features for vibrations and the sound. Okay, once these sound and vibrations are damped, certainly your the comfort level will get enhanced. Okay, then lastly we have the one more interesting feature related to the adhesive joining. If the say big assembly is being made, okay, like this, using the rivets, okay, like this, or using the weld, not spot welds, but the, like say the addition of the metal is being, so welding using the filler. Okay, so the rivet and the welding using the fillers, these simply increase the weight, but adhesive joining also increases the weight, but at moderate level. So as compared to the riveted joints and those consumable welding joints, the adhesive joining contributes less to the weight gain. So indirectly, you can say the weight saving is another important feature, especially in the automotive industry, where if possible, you can avoid the rivets, or it can be used in combination with the rivets if very high reliability and the components is very critical for the performance. Okay. Coming to the last section of the today's presentation, that is about the limitations of the adhesive joining. You know, the peel strength of the adhesive joint is very poor. Okay, so this is one very limitation. See, the operating temperature limitation, you see, these cannot be used at, you see, usually 82 degrees centigrade is the normal operating temperature, you see, below which these operate sufficiently, but in some cases it can go as high as, like say, 150 or even 250 or 60 degrees centigrade, but those are very costly, very difficult to process. Okay, so the operating temperature limitation is the another one. Okay, you see, the process principle wise it looks very simple, but the kind of the controls needed for process uh, for processing the adhesive bonds, those are very costly. So the kind of equipments using which it will be applied, then the quality controls will be ensured. So the process control is these are very costly for the adhesive joining, and sometimes you see, there is a possibility the curing time may be long. Curing time can be another aspect. Like say, some of the adhesives may be needing half an hour or 1 hour to get the desired strength. Okay, so that may be affecting the production cycle itself. Okay, then the next point is, you see, there is no common NDT technique can be used uh, for uh, for ensuring the quality of the joint. You see, the kind of the NDT techniques that are known for the metallic joints, for quality assessment of the metallic joints, those are not actually applicable for the adhesive joining. So no common NDT techniques are helpful for ensuring the quality in adhesive joining. So what are the ways to? One is like you just control the process. Huh? And process is controlled in such a way that you consistently get the same quality. So that has to be optimized, and that is optimized through the, obviously you develop a lot of joints and then see which is giving you the which set of the parameters giving you the desired set of the performance of the adhesive joint. So the simple way is perform the destructive test, develop the lots of joints, and perform the destructive test to ensure that mm, you get so basically the joining procedure specification is established, and that is done through the destructive testing, and once those are done, then process is controlled very closely in order to ensure the joint. Okay, the lastly, the another limitation only, the limited service conditions. I have already said about the temperature. The same is true for your so not just temperature but also humidity and the stress conditions. Moderate stress conditions, moderate temperature, maybe moderate humidity is fine. Otherwise, these will get decomposed. These will get damaged or destabilized. So there will be failure of the joint in that case. So I think that's all about the adhesive joining. I've given some idea of. In next lecture, I'll be talking about the different adhesives which are used, and then various types of the adhesives like thermosetting adhesive, thermoplastic adhesive.